issue to habitat. So what we do is drones. Just at a quick show of hands, how many people in this room are already leveraging drone technology? Okay. So I would say we probably got about 15 people in the room. Out of curiosity, for those of you that are also leveraging drone technology, are you also leveraging ground robots or aquatic underwater systems? Nobody. So about 2 miles away from here, if you walk outside that door, is the Norton Test Range. The Federal Aviation Administration has granted us the authority to create research airspace right above the Santa Ana riverbed. And what that enables us to do is to actually gather data and work with everybody in this room to basically determine how technology can be leveraged to make your jobs better and more efficient. Notice we have the mountain range. We almost have the dam. I can let the cat out of the bag. I'm going to go right up that mountainside in another year. Right now we have 15 square miles of research airspace, 10 miles long end to end. You have 1,000 feet above ground elevation and 1,696 areas of launch location, plus another 453 around the airport. For those of you that have drone programs, you know that launching is one of the things that we need to be mindful of. How would you guys feel if I told you I could launch an aircraft over 1,000 pounds? Imagine the technology that we could put on board these systems when I have those types of airframes that could be leveraged. Right now, some of the things that are holding you guys back is perhaps that you don't have technology as small as this that can fit in your pocket. Exoskeletons, ground rovers, underwater systems, and aerial platforms are all things that we are allowed to validate in the interest of research and data. We know about sensing, and we know that technology is now as good as what's in my pocket. But with robotic technology, we can see all the lights of the spectrum. And with that, you have your vegetation health, your water stress, your NDVI imaging. You can do wildlife monitoring, ground seepage, hydrologics, insights, terrain modeling. You guys can read. You can also do ground penetrating radar and locate an obstruction underneath the surface. Maybe you're trying to figure out why something is not getting from point A to point B, and there's something underneath there. In 2018, I tracked a honeybee just by setting the drone to the core body temperature of the bee. 95 degrees. When it was in motion, it heats up. Drone picked it up. I was able to follow it. The technology is available to you guys, and it's just as good, if not better, than what's in your pocket. We want to help you guys build better data and help you guys make the right decisions. It's not just aerial. It's not just ground. It's not just underwater. Sensing platforms. Flying over the head. Someone was talking about remote sensing. What if I put a sensor in an area in the range, and then I fly over it with a robot or drone, and because I'm not doing any damage, I'm just flying overhead, and I'm passively reading the sensor and getting the data that you guys need. I can cover a lot more ground that way. So with that, I've already got my 5-minute warning. I'm probably about a minute and a half left. I'd like to answer some questions and let you know more about what we're doing. I can hear you.
So for any of the drones, have you looked at using drones and some of the light technology that is used to kill root systems for invasive species plant management
No, but that's,
and automating that on hillsides where we otherwise couldn't reach seed
so what
banks.
you're thinking of doing is actually putting some sort of light emitting sensor underneath the aircraft, flying to an area that you're locating for.
Zap the root system and basically kill the invasive species like arundo and things, and just set up an algorithm to go across hillsides.
The answer for you is that's what we're here for.
Okay, cool.
Zip.
Rock, paper, scissors?
I think I flew at 200 feet, and I was able to give you data accurate within like 1.2 centimeters. And I flew 32 acres in 9 minutes. So, it's a lot better than walking around on your feet.
Okay, thank you all so much for sticking around. I'm Rachel Chalk. I'm a researcher with the San Diego Zoo Wildlife Alliance, and I am really excited to talk to you about the San Bernardino kangaroo rat today. So our program has been working with these guys since about 2012, so I'm going to give kind of a big picture overview of some of the research projects we're working on, and I'd like to thank everyone that's helped. A lot of people in this room from different organizations and agencies have supported this work, so huge thanks to everyone for doing that. So San Bernardino kangaroo rat, or SBKR, historically occupied about 326,000 acres of habitat. They're restricted to a pretty small range within San Bernardino and Riverside counties. They were listed as endangered in 1998, at which point already 95% of the habitat was estimated to have been lost. In 2002, 33,000 acres of habitat were designated as critical habitat for these guys, but by 2018, only about half of that was considered functional. And in 2021, they were listed under the California Endangered Species Act, primarily due to ongoing threats of habitat loss and fragmentation. So these guys are restricted to 3 isolated populations, the Lytle and Cajon Creek, the Santa Ana River, which we're all very familiar with, as well as the San Jacinto River. These are located among major waterways and surrounded by the gray is urban development. So you can see that their habitat is pretty restricted, and these populations are not able to be connected naturally anymore. So the habitat that they utilize is alluvial fan sage scrub, which is the habitat along the waters. This was, as we've heard, characterized or historically characterized by periodic disturbances, where flooding would scour the vegetation and create a matrix of early, mid, and late successional stage habitat. And these guys prefer that early successional habitat with more open ground and sandy soils. Due to the increased urbanization, including the dams, levees, channelization of the rivers, there's been a reduction in those natural disturbances, so there's less reset of that habitat, and a lot of it has moved to more mature habitat, which is part of the reason why so much of the designated critical habitat, even if it's conserved, is no longer considered functional. So our team was interested in understanding what the remaining habitat was, both on a landscape level as well as a microhabitat level. So a former colleague of ours, Sarah Hennessy, created a species distribution model for this area. So she used about a decade's worth of trapping data from a lot of different organizations and mapped it against different landscape features shown on the left. She found that the parent soils as well as the alluvial scrub cover were the best predictors of where SBKR had a suitable habitat was remaining. And the map is showing the areas in dark green as the most suitable remaining habitat, and what you can see is there's not a ton of that left. The areas that are in tan and light green are low suitability, but one thing that we were interested in was identifying areas that, if there was active restoration and management, could be made more suitable for this species. We also conducted microhabitat surveys based on our trapping efforts throughout the range, and then on-the-ground habitat surveys. And so this is looking at the abundance of kangaroo rats with a variety of different factors. And what we found here are that there are different levels of vegetation that correlate with different levels of abundance of SBKR. And so, for example, you can see in the top, SBKR abundance is positively associated with low levels of shrub cover, but negatively associated with higher levels of shrub cover. And the idea was that these targets would help inform on-the-ground restoration. I've included some QR codes throughout here. We've published some of this work, and so those should link to those papers in case you're interested in getting more information on any of that. We also conducted a project looking at their below-ground habitat use. So these are a burrowing fossorial mammal. And so this was done in collaboration with Christian Broderick from Stillwater Sciences over at a site that's not far from here on BLM land. This was about to be remediated from its history as a shooting range. And so we worked in collaboration with the landowners as well as other partners to identify where the kangaroo rats were. We documented their burrow locations using both camera traps, direct observations, and trapping efforts. We trapped and removed all of the animals from the site, and then we poured plaster of Paris into their burrows, excavated them by hand, and then we were able to document both the structural features of their burrows, the size of these structures. The longest one we excavated was actually 30 feet long, which is pretty amazing for such a small animal, as well as how they're using the shrubs and the root cover to integrate into the structure, and the soil characteristics of those burrow features. This is work that we're hoping to continue to do in additional areas because we want to understand how the habitat actually influences the structure of those below-ground burrows. A big project that we're working on right now is to better understand how habitat enhancement and connectivity are influencing the kangaroo rats. And so one of the directives in the recovery plan is to enhance both occupied and potentially occupiable habitat for these guys. So we're partnering with different landowners to experimentally manipulate the habitat. And so this map is showing a schematic of that. At each site, we have 4 acres, and each of those acres is broken up into quadrants, and we're applying different habitat restoration techniques to each quadrant, and then looking at both the vegetation response over time as well as the kangaroo rat response over time to try to understand if there's different techniques and treatments that they prefer. We're focusing on areas that are really outside of the alluvial, outside of the area that's going to receive natural floods anymore. And so we're looking at non-fluvial processes to do this restoration work. So this includes light scraping, sediment addition, and targeted herbicide. And one of our questions is about, even if we can achieve and maintain the habitat targets, particularly for that bare ground, if the animals are going to respond more favorably to areas that have had more recent soil disturbance, which is really the environmental cues that they evolved with from the scouring of the fluvial processes from the rivers. So this is showing some of the corridors that we're creating. We're also looking at connecting the areas of restored habitat to occupied areas to promote sort of the natural movement of kangaroo rats into these areas. And so we set up at each site a series of different either linear corridors or patchy stepping stones, and then treated them with either scraping, light surface scraping, or enhancement, which is a combination of grass-specific herbicide and sediment addition. And what the map at the top is showing is the intensity of use of both coyotes, which are shown in the tan circles, and rodents, which are shown in the dark blue circles. And so this is preliminary data from one of our sites, but so far what it's showing is that the enhanced treatments are receiving a lot more activity from both types of animals than the scraped treatments. And this is, hopefully going to provide more information about the ways to create the corridors, to connect enhanced habitat to occupied habitat, as well as the treatments that we can use to really promote their usage by the target species. So while connectivity is really important to get animals to move within a population, as I mentioned, we know that these populations are isolated from one another. So our team in conservation genetics at the San Diego Zoo has done a lot of work looking at the range-wide genetics of the San Bernardino kangaroo rat. What we found, sort of in a nutshell, is that the greatest remaining genetic diversity is in the Lytle and Cajon Creek population, followed by the Santa Ana River population. The San Jacinto River population has the lowest genetic diversity, and it also has worryingly low effective population sizes. And so this really suggests that there is work that needs to be done to augment the genes, as well as really some modeling has shown that that population is also at the greatest risk of extinction in the next 100 years. And so one way to do this when there's no opportunity to create that natural connectivity is through assisted migration or translocation, moving animals between populations. This is something that our group has worked on a lot, and I think a lot of us think about translocations in a mitigation context. And we're interested in developing the techniques and improving the success for this species to make them more successful for a conservation context. So some of our work has been to look at ways to improve soft release, so that's using acclimation chambers or potentially fencing to keep them anchored at the receiver site. Using telemetry to track their movement and settlement and understand their habitat use in that critical period following release, as well as long-term monitoring like using pit tag reading stations, as well as using genetic techniques to look at the reproductive success of animals that move, as well as the introgression of the genes into the resident population. And so finally, one project that we're getting started on right now is a receiver site evaluation and prioritization process. And so in order to make translocations even more successful, especially in a conservation context, what we really need are suitable receiver sites to move these animals into, whether that's for mitigation or for conservation purposes. So we're partnering with organizations to develop really a list of the indicators that we think are going to improve the translocation success for SBKR and identify how to improve these at specific sites, because often there's a mismatch in the timing that development happens and you need to move animals and how long it takes to actually restore the habitat and improve it for SBKR. And so what we're doing right now is working through the list of those factors and working with some amazing landowners throughout the remaining range of SBKR to pilot these trials there this year and to really start to get a handle on improving the habitat and creating suitable areas to translocate animals into, both for genetic augmentation as well as hopefully expand the amount of occupied area for this species. So I just wanted to end by saying we all know that conservation is a complex puzzle. We are working on different pieces that we hope will help solve this and improve the future for this species. So thanks so much, and I'm happy to take questions if I have time.
Have you checked iNaturalist to see if anybody has identified the kangaroo rat outside of the areas, those three major populations that you mentioned?
Yeah, so they are a little bit hard to identify. There are 19 species of kangaroo rats, and a lot of them look pretty similar when you're not holding them. And so we definitely have gone through data from permitted biologists from their records of trapping them and surveying for kangaroo rats in this area. Yeah, thank you. Question at the back?
Thank you. Yeah, I was wondering if, like, from the genetic analysis and the habitat analysis, like, there were any correlations between, like, habitat quality and diversity of the different populations and kind of like habitat condition, et cetera, and if you were able to draw any more conclusions out of that.
Yeah, we haven't been able to look at, or I guess we haven't yet looked at correlations between habitat quality and genetic diversity. I will say that the populations that have higher genetic diversity, we know have higher connectivity because of the way that the habitat is structured. In the San Jacinto population, it is sort of more like a linear feature, and so it makes sense that there's less opportunities for gene flow within the population, and so I don't think it's particularly surprising that that one has less, I think, mixing among animals within the population than in the other two, where there's more connectivity within the population.
So I was really interested about the habitat corridor studies that you were doing, and just out of curiosity, do they respond? Would they respond to like the coyotes or predation pressure? I mean, is there any sort of, if you had too many coyotes going through an area, would they avoid it, or are they pretty good at sort of doing their business regardless of who's around?
That is actually something that we're interested in looking into. And so the very preliminary study looks like the coyotes are sort of, the kangaroo rat activity increases and the coyote activity increases following that in a pulse. And so I think that there are no areas within the habitat that they're not going to encounter predators, but we are interested in using the camera trap data that we have, which has a high degree of spatial and temporal specificity, to see how those interactions change through time. So we don't have enough data yet to address that, but we are collecting that as we speak, and so maybe this time next year we'll have a better answer to that question. Thank you.
Our next panel.
Okay, someone gave me a mic and said I'm in charge of a panel, so we'll see how it goes. Are we still good with the 30 minutes? Okay. You do, yes, that sounds great, yeah, yeah. Okay. This is the beginning of the end, not really, but we're gonna hopefully wrap up with what I hope will be a dynamic conversation. Hopefully everybody here was able to hear each one of these individual speakers today, but from my own observation, even before I got to hear them all speak, I was like, this is an interesting group of 4 people that are all bringing very different perspectives from their work, but yet there's this opportunity to connect and to connect these ideas. So that's really what this panel is going to focus on. I have a couple questions. How successful they go, I don't know. We'll see where we go. Before we dive into a particular question, maybe we'll just do quick introductions. Myself, Lindsay Tunis, restoration ecologist at SWCA, and I will be moderating and not speaking much.
My name is Dave Kraus. I represent the UAS Center at San Bernardino International Airport.
I'm Rafael Mazor from the Southern California Coastal Water Research Project.
I'm Laura Jansen, also at the Southern California Coastal Water Research Project, or SCORP.
I'm Rachel Pickstein, and I'm an environmental biologist and ecologist, and I'm a PhD student at Loma Linda University.
Wonderful. Okay, now I get to pick which of my questions we're going to do first. I think there were quite a few of the most recent presentations that I think really illustrated the conversations that we regularly have to do around trade-offs. So I wanted to put that concept out to the group, and I have kind of 2 ways that we can capture this question, so I'll put both out there. You decide what flavor you want to take, no pressure. So as climate stress increases, how do we balance ecosystem protection with human benefits like recreation without undermining long-term watershed health? So that potentially is very specific to one of our presentations earlier, but I think each of us probably have a perspective on other types of kind of competing interests. The second is how can we balance various issues that may naturally conflict, such as invasive species? We have to put money in. Some species provide value. Nature-based recreation, we know that people love what they know, but how do we make sure they don't overlove it? Flood control, we need to move water fast, but not so fast that we then don't have water for the ecosystem. And just overall ecological health. So that's a whole smattering of ways we could take, and I don't think there's one right answer, but would love your thoughts maybe either from your own topic today or bigger picture topics. So balancing, how do we make decisions? How are we balancing the natural conflicts that might arise between competing interests? And I don't know if anybody feels comfortable diving in.
I don't think I'm going to remember all those questions, but we'll start with the first one. I don't view recreation as being a bad thing. I think those that are interested in the recreational use are going to potentially be advocates, and that's very beneficial for what everybody's trying to collectively do. There are the experts in the room, and then there's me sitting here learning. But I'm an advocate, and I think that has value too.
I'd probably just add, decision makers have a very difficult job, or at least it's a hard job to do well. I think one of their challenges are, first of all, to understand what are the potential goals that they have, and that's not always very clear, particularly in these like urban environments. What's the right ecological goal for something like the Santa Ana River? And then, you know, quantifying the ability that they achieve those goals, I think that is a major information gap that at least the scientific community can help fill. You know, I don't have a clear recommendation like what is the right balance. That's not my job. It's well above my pay grade. But I do think that what I can do is help these decision makers, give them tools that they can use so they can explicitly understand what are the impacts of their decisions on that balance. I have an opinion on what I think that balance should be, but it's no more important than anybody else's. And I would just add that it's important not just for decision makers to have access to that information, but the community as well, so they can, you know, advocate for their interests as well.
I think I'll start with something that comes to mind from one of my early times in working in ecology for now over, like 12 plus years. I worked at an agroecology research station in Florida, and it was really cool because we needed to work directly with cattle ranchers to assess how we could improve the ecology of very sensitive spaces like isolated wetlands, but acknowledging the fact that cattle ranching was going to happen there regardless, but we could try to work with them to improve it. And it really taught me something about the fact that there's always going to be a conflict of interest, but if you can meet people where they're at, such as in an urban setting where maybe we're not able to remove every invasive species, but like people can value them, maybe it's more of a mosaic of spaces. Some are much more naturalized and protected and restored, and some are very altered and full of invasive species, but they're still providing a service. And it can be a tough pill to swallow, but I don't know. I guess what I'm trying to say is it's all about thinking about what capacity you have to do there and what stakeholders are involved, and yeah.
I would agree. I always advocate that hunters and farmers are some of the most sustainable and environmentally conscious people I've ever met. I'll never forget being in my mid-20s and early in my relationship, a decade with my husband, probably in the first year we dated, we went to West Virginia and we went whitewater rafting, and we did the most touristy stuff, but we like to camp, and we ending up on the whitewater rafting tour led by the good old West Virginia born and raised moonshiner who brought his moonshine to share and his heavy accent, and of course immediately me being a recently graduated student, you know, with my multiple degrees, all that, being like, oh my gosh, this, you know, oh my gosh. And by the end of the trip, he had pointed out every urbanization impact. He had pointed out every contamination of the river. He knew every species, whether it swam, ran, or flew. And he had one of the strongest conservation ethics that I had ever seen. And so I always say, never judge someone by their age, by their locale, their skin color, just judgment. We need to look at every animal, people, situation, individuals, and the ability for every human brain to contribute to a problem. I forget who said it, but there's a famous saying that says, and someone's gonna remember it in the audience, I know, but a famous scientist once said that I'm less interested in the complexity of Einstein's brain rather than the fact that, 24 or, how many hundreds of people have died with the same complexity as his brain in the sweatshops and in the cotton fields. We have to look at the value of every human and their experience, and absolutely, conservation comes from the heart of the people and the locals who can embrace the species or can exterminate it.
Awesome. Very well said. I appreciate everybody's perspective. Maybe continuing down that concept of, it seemed like one of the common themes that came out of everything you said was just kind of knowledge sharing in addition to connecting to people, and wanted to talk a little bit about your own experience in how you go about knowledge sharing, how in your own work do you find it most successful, whether that's with the community or other stakeholders, but everything from databases to public talking, whatever and however you think that makes sense, but knowledge sharing in all forms. What have you found to be most successful in your world? Oh yeah, actually, can we talk a little bit about that? Because as part of our email exchange, her first response was like, well, in my various Comic-Con things, and I was all, I had to reread it 3 times. I was like, I really do need to know more about this.
Okay, and since I'm still in the recruiting phase and I'm in a room full of STEM and STEM enthusiasts, I'm gonna say we are still taking exhibitors and volunteers. Myself and one of my best friends, who's also a biologist, she's an entomologist, herpetologist, Caitlin Garcia. We are the science directors for Phoenix Fan Fusion, the largest Comic-Con in Arizona. And we did see over 135,000 people last year and had Hayden Christensen, so we're big and we're growing and we're coming after you, San Diego. And we brag about the biggest and most well-developed STEM, it's STEM with arts, education and hands-on learning program of any comic convention in our side of the world, beyond just our country. And we offer more than 70 to 100 STEM panels. We call it Sneaky Science. It was founded by Dr. Rebecca Brubaker, who has a double doctorate in Ebola research and medical cellular things I don't understand, but she's brilliant. And she started going back to, I believe, 2016. I joined in 2018. And I did panels, and so we do everything from real bioregeneration, the science behind Deadpool, what's possible, cold fusion, frozen science, talking about frogs with antifreeze blood to describe Disney themes, and basically bringing fandom and science. And we tell people the goal is to sneak the science in so that they leave with the education and the knowledge. We do without realizing they're learning the science. This is now going to be the 5th year. We also have something called the Discovery Lab, which is now a 5,800 square foot hands-on learning area in the open exhibit space. We started in a solo room with 1,500 square feet. We also have 3 panel rooms that hold 150 people each. And our panels have 4 experts. We take people from all fields. They have to have at least 5-year industry experience or at least a bachelor's. And you can get professional accreditation and teacher professional development hours for working with us. And we give you, of course, free tickets for being a part of this. It's either, and I can break down those details later, but you can volunteer, you can be an exhibitor, you can be a panelist. But we have a network of over 300 STEM and STEM professionals and just STEM hobbyists from 8 states and 5 countries who come out every year for our free tickets and to help us bring this awesomeness. And it's also the STEM hands-on learning room. We've had San Bernardino County Museum the last 2 years, my own Loma Linda University, Dr. Bill Hayes Lab, my nonprofit, as well as 8 different programs from ASU. We've had the Lowell Observatory for years, lots of really amazing programs, as well as local small environmental consulting firms and you name it, podcasters, all these people who are just big advocates. And I tell people you have to just share a love for STEM advocacy and outreach and education. And being that Caitlin and I have taken the organization as the main leads just in the last year, we are very excited to continue to grow it. And we're now doing hands-on outreach programs in the Valley through places like Gamers Guild, boutique hotels, plant stores. And the goal is just to, I call it, our new rebranding is Ratatouille. It's Ratatouille science, making science palatable and not only just like you can understand it, but you take ownership of it. And making people take ownership of science is a lot better than just talking at them. So we had, I'll wrap it up with one of the biggest compliments we got last year because it was our first year in an open space and they doubled. Every year they've doubled our space. So love you, Mac and Real Time Steam and Square Egg Productions who host Phoenix Fan Fusion. We love all them and they have just continued to give us more and more freedom. And so last year we had, we get several interviews from articles. We get lots of fandom to come and talk to us. But the people who came up last year, we had someone give a response, basically sent in a comment, and they said that they were in our area for over 2 hours playing with various things before they realized they were in the science area that they've been already looking for. Like they were looking for the science area and they were in it for 2 hours before they realized they were already there. And we had like real sheep brains, we had 3D printers, we had robots that you could program, not to mention a variety of live animals, including rattlesnakes, live stage program with animals, and of course all not fear-based, but ethical, educational. We talked about enrichment, zookeeping, all of those things, and it was fabulous. So if you're interested, talk to me. I can always take take more volunteers, and we are still taking more panelists. We're taking more panel suggestions. And if you know or have or work for a company where you'd like to have a booth and do free table for fundraising, worth its weight in gold, I'll tell you. You can't buy a space in open exhibit hall, but that way it gives you the ability to network and fundraise and also promote things. And we're looking for more people. It's only a 5-hour drive straight to Phoenix. So that's my big spiel. That's my platform. Thank you for letting me say it. But it's my favorite thing I'm a part of. I can't say enough about it. So my answer to the whole question is public outreach and education. We call it fundraising. Thank you.
Thank you for sharing all of that. Yeah, no, I feel like that is, illustrates a lot of different avenues of engaging, and in particular engaging outside of where you might traditionally think that these conversations are happening. So I appreciate for sharing that spectrum. Curious, Laura, what you think?
Well, I guess I might take this in a slightly different direction.
Yeah,
I
different
really
works, yes,
appreciate
yeah.
it though. Wow. Because when I also think about knowledge sharing, I also think about sharing among the many disciplines and agencies you work with. And I think a thing to think about when you're like, ooh, they have some data or some things that I could get out of, also think about what can you give them? Because I think too often we're looking to take and use, and that's great because a lot of people are like, I built this tool and I want somebody to use it. I worked 5 years on a PhD and I want someone to use this, but you also should be giving back and having an exchange and building sustainable collaborations, which I think really helps make the environment that we are building and the community we are building more inclusive and more fair.
I think those are really great points. I just would add, I think I would like to see a slight shift in the way we train grad students in sciences. I think we often have the perspective of the publication is the endpoint of the research, but it really should be viewed as the starting point. Once you've got the science out there, what do you do with it? And I think that you have to really be very deliberate and conscientious about how you use this public science to affect management, to affect conservation. So I think that's just sort of like a little bit of a view shift that we need to see more common in academia.
Yeah, no, I like that a lot. Did you want to add anything?
Can I just add? Yeah. From what I'm observing, it looks like the data exists. It's just fragmented. There's not enough collaboration, as you guys are all saying, but the data's there. So I think that's really kind of indicative on like what we do at the airport is when people come to us for research, it's a relationship. We help them gather the data that they need research-wise. We make sure that they don't get themselves in trouble with, regulatory compliance. And then I can't disclose the projects, but I try to share that knowledge and carry it on. And I think, from what I'm hearing, you guys all have it. Just keep talking about it.
No, I appreciate that. I'm going to do a quick drop for, I think to your point, there's so much amazing data, and we talked about this over the last couple of years of like how to, bring more of it together. And there are some tools already being built in California. I know I mentioned this 2 years ago, or maybe it was last year, I don't know. But EcoAtlas is a state-funded tool that's run by SFEI, but it's housing currently huge amounts of data sets, and we don't have to start from the beginning. So I think to your point, the data's here. I think there might already be platforms. It's kind of like who's gonna, who and how drives that ship a little bit, and then, or drives the bus, I should say. I guess a ship is bigger, so we'll do a ship, and then everybody can come on the ship. But I think that would be a really exciting future for this group, is to be bringing that together. And Rafi, to build off of what you were just talking about, just with data in general and sharing, I finished grad school 20 years ago now, and the work I did had management implications, and yet you don't leave it with the ability to, like, it doesn't land on someone's desk, it didn't go somewhere, so other than me maybe talking about it randomly, like, it doesn't have that. With that same kind of peace and peace of mind, that academia space versus decision-making space, I'm curious as a group what people think about how we can expedite decision-making using good data within the academic space, but also within the I keep calling you guys joint powers, but those kind of research centers that we have in California, and the research that's being collected out here. Like, how can we make decisions without worrying about so much about making the perfect decision? You know, like we slow ourselves down because we're waiting so long to make the perfect decision. I'm curious what you specifically have seen, and then what the rest of the panel has observed.
I think that's a really great question. Why are some of these decisions, why do they take so long? Part of the reason is it's actually good because decision makers can take the time to assess the state of the science, to really engage with their community, their stakeholders, to figure out, you know, what is the right decision to make. But sometimes things take a long time for reasons that are maybe less admirable. Sometimes decisions are delayed simply because the outcomes might be unfavorable to people. I actually see, like, they have a hard decision to make, so they'd rather not make a decision at all. That happens a lot. I don't really know how much a scientist or a researcher can do to help that. It really requires, you know, clear political will and backing throughout an agency. You know, if your leadership is not going to back you up on a hard decision, you're not going to make that decision. So I think some of these are a little bit broader than what the research community can do. But I imagine some people in the audience might actually have some good stories to share about that.
Okay, I feel like I talked a lot in this question. So, yeah, I really, it's hard to really draw the connection. I think it's about continuing to keep programs. I mean, one of the things I did in the very brief moment I had before I talked was walk around to some of the tables outside, and I get to talk to all of you, and I would love to before we're done. But just hearing every table talk about education, hearing every table talk about multiple initiatives, hearing you know, like there's already the systems in place there. It's a lot of us collaborating across what we see as political lines, what we see as modern limits, and really becoming creative and not letting things get in the way. I mean, it's hardcore. I mean, I'm a TED head. Okay, I learned what that was this year. I'm very obsessed with Teddy Roosevelt. And then you go to his hometown to be a speaker, and well, his hometown where he lived in, like, you know, in the Dakotas. Okay, like where he found his conservation ethic, and standing in what they call the cauldron of conservation in the Badlands. Oh, goosebumps, okay? Because, I mean, it's just this idea that, you know, do not let someone tear from your country its beauty, its wonder. He didn't know the term biodiversity then because it didn't exist till about 20 years ago, but biodiversity and the idea of our habitat complexity, him and John Muir called the redwoods the cathedrals of a forest, that our true nation's pride was in our parks. We don't have crown jewels, we have parks. And if you talk to anyone, like one of my best friends over, you know, on the East Coast, who's a professor, and she's from Belgium, Kelly, I love you, and she's a behavioral entomologist. She came to study in the United States because Belgium has no wolves, they have no bears. Anything cool was killed off so long before, you know, in the olden days of history, and we still have it, and so we need to protect it. And I think it takes sacrificing a lot and realizing that means giving up modern comfort, convenience, and coming together to preserve what matters before it's gone. Because what we know about ecology is that the number one thing people don't understand is how complex it is. And it's like trying to fix a car with a 5-year-old's knowledge and chewing gum and duct tape. That's what people try to do when they release an invasive mongoose, you know, going, hey, it'll solve this problem, and then it just eats sea turtles, you know, sea turtle babies and their eggs. So we have to really be incredibly working together and be the best humans we can be, or we're not going to get a lot of progress. But that means, again, including all of us. And I'm going to plug Comic-Con one more time. Going back to that is that it's about diversity and inclusion. And when I tell people, like, we promote diversity, like, I have no less than 5 amputees out of a group of 50 who volunteer regularly at my tables. Like, that is an incredibly high percentage of people who are missing a limb, and you better believe they cosplay up their disability rather than hiding it, and it's amazing. To see people actually put their best whatever forward, that's one of my jokes, and really be able to live who they are and just be unapologetically their best self. And when we can cure that internal mental health, people are a lot willing to help other people. Or like we say, there is no such thing as a hungry conservationist.
I appreciate I feel like exceptionally inspired overall, and then I have to step up my my motivational game. But I appreciate all of the, like, big picture thinking, because I think that's really what's needed here. Did you want to add anything to that question? Otherwise, I'm going to roll in. Do you have anything?
I mean, the only thing I'm really thinking about is legacy. we have a responsibility to just bring on the next generation, and I think that's where the leadership changes are going to occur. So.
Do I have like 5 more minutes? Where are we at? Yeah, okay. Okay, I'm gonna wrap up. I'm gonna change the way I was gonna ask this question. I have a tendency to be a little sarcastic, and so I'm gonna start by saying what I was gonna ask, and then I'm gonna reframe it. So I was gonna ask, like, when do we consider giving up? When are we done? And Heather got this question. We were at an environmental conference once, and she was presenting on the HCP and all of this, and someone's like, why are you even taking care of the Santa Ana River? Like, it's already so degraded. Like, it was really a depressing question to see someone ask, but more important, do you remember that? I was like, wow, that was really, just asked that in a room full of people. But for those of us that work in this watershed, which is why I'm not gonna ask the question, because you all wouldn't be here if we were giving up. Like, if you live in Southern California, if you work in the Santa Ana watershed, oh, you have your hat on, that's good, that was where I was going. And Heather says this, and it's actually why when I first met Heather, we were standing on a bluff looking at a project. And I don't know, I threw out a crazy idea and she's like, that's awesome. I was like, oh, you're my people. Because so many people hear a crazy idea, like we're gonna take cement out, we're gonna remove that, trash pile, we're gonna whatever. And they're like, it costs too much, it's too difficult. But what is it? Too difficult is not impossible. What are we doing? Really hard does not equal impossible. And I think that I'm so glad Heather made hats, but more importantly, I think that philosophy is represented in this room. So with that in mind, I would love it if each one of you might share something where you've seen that concept fulfilled, or you have dreams that it will be fulfilled. I'll start with sharing mine, which was one of my examples. So I am strongly unhappy that we call non-native invasive grasses naturalized. For 2 reasons. This is a pet peeve of mine. One, for anybody who's a layman, they think naturalized. It must be natural. It must be from here. So I think the narrative itself is descriptive. And 2, it literally means I gave up. I gave up. They're too expensive. It's too expensive to take care of. We're never going to tackle it. And as a Southern California biologist, I know we have areas where we can manage non-native grassland. Same thing with I'm so excited to go zap fountain grass in the canyon that we're working on post-fire. I was like, yeah, are there laser beams we can strap to a drone? Let's do that. So I am not going to give up on that, even though I understand that they can provide some value, but they don't provide the right value. So I'm just going to keep on that soapbox. So it hasn't been fulfilled, but I've seen it done in places. So, and this doesn't have to be biologically specific. I think the concept should apply to all aspects of life, so whatever's specific to you.
That's a really good question. I'm going to actually draw the analogy away from biology and talk about what we do. We operate in a regulatory space when we're dealing with aviation, and we're literally trying to survive as the laws that are allowing us to operate are changing. And on top of that, we're trying to innovate and become a research facility. I just keep looking forward. And I try not to get frustrated by all the things that are in the way. I can't relate it to biology, but it's the no give up attitude and not accepting that something that is invasive is considered something natural and leaving it like that.
How many people in here that are biologists or work in this space identified with every word that was just said other than aviation? How many of you literally just described my life? So yes, so just so everything you said is spot on to every person.
So I think in terms of when do you give up? I don't think that. Well, that's the thing. I don't think I'm not the one to make that decision. That's a societal decision. It's a hard one to make, and the people that have to make that decision, I don't envy that job. I can, as a scientist, figure out what kinds of flows are needed to restore steelhead to the Santa Ana River or the LA River, or what do you need to get a healthy benthic macroinvertebrate community? Do you have to rip out all of the concrete for dozens of miles? And then somebody else has to decide if it's worth it. I guess we're talking about reconciliation ecology, kind of what can we achieve given the current conditions. I guess I would like to see, I don't want to call it giving up, I would say clarifying what your goals are. And like, do we want to invest, millions of dollars or billions of dollars to, restore the ecology of parts of the Santa Ana River that in highly questionable restoration methods that haven't yet been proven to work? Or do we want to use that money in some other way to benefit the community? I think we have to have a clear sense of like what our goals are. I actually think that's sort of one of the reasons why I'm working with Laura on trying to be able to assess some of these human benefits, so we have a better sense of what are our investments trying to accomplish. In my view, a water body, every water body in an urban area should be an amenity, not a blight, and that's not necessarily what we're achieving right now. And so I think if we can figure out what we can do to make these urban waterways something that the community really celebrates, then that should be that would be the goal I would aim for.
Good stretch goal, but I think I'm all in.
I guess I'll say is, so I mostly grew up in California, but then I went away for several years, both for grad school and jobs, and I always thought about how, fierce the debate for water is in this state. I mean, you can drive through the Central Valley and it's kind of screaming in your face. You've seen the billboards. And when I got to hear about the Klamath dams coming out, it felt like there was some real hope, because I did my master's on dam effects, and people were like, yeah, it'll be cool if those dams come out. And turns out those are also coming out soon, baby. And so I got really excited when I got this job over just shy of a year, because I'm going to work directly on environmental flows with, I'm going to give a shout out to some really incredible hydrologists, yeah, you, Chris, who remind me that we have to just keep pushing. It's going to be hard. You're on the bottom of the totem pole often in terms of where the flow is going to be directed, because there are some louder voices in the room than the environment. But you just have to keep pushing, and it's going to be hard. But like, if you have good support systems and great networks, it makes the work worthwhile. And yeah, sometimes it can be really hard to feel like you're not being heard by the regulators, the policymakers. But if you just keep showing up and pushing forward, I see things are happening and you want to stay in the room. So yeah, that's why I'm also really excited to be back in California.
Congratulations on your new job. That's so awesome. I don't know. I'll be honest. The reason I'm here is because I'm from Michigan. And being from Michigan, we do two things really well. We're really good at being awesome to our water, and we're really good at being horrible to our water. So we protect it better than anywhere, arguably, in the world with the Great Lakes and our initiatives with, the multiple states in Canada. And, my dad comes from environmental chemistry, my mom's a biologist, and growing up in Michigan, with a strong water ethic. We grew up on our own well and septic. I knew how to take care of it from the time I could walk, knew what not to put down the garbage disposal, all those things. But very quickly, by the time I was in high school, and arguably by the time I was an undergrad, half of all amphibian and reptile populations in the state were down by half. In 20 years, the things that I loved more than the world and spent every minute catching knew that the chorus frogs were quieter every spring, the garter snakes were harder to find, the turtles weren't basking in great clumps, there was a lot more red-eared sliders, even though ours are native. There was proportions changing, and it's simply from massive urbanization and the use of road salts. And the constant there's always more, just keep building in Michigan and destroying our water source. And then you move to somewhere like Phoenix, where I've been the last 8 years, and really understanding water issues from a different point. I was a part of the Flint lead crisis and some of that advocacy and outreach for those people back during that time. And what I've learned about water pollution is that we have to all be here. So I was very excited to get a random email on a Thursday about this watershed conference, and I was like, yeah, back in October. And I was like, I want to be a part of this. And it was fun to learn about this watershed, and I'm so thankful to be here because I think that's where we start. And I've never met anybody involved with the watershed that isn't just an awesome person who really just cares about conservation. And it encouraged me to be here and to want to share and talk and see what kind of resources and ideas we can collaborate on, beyond my really quick slideshow of the things you already knew about your watershed. So, I would go back to it's never too late. And I'd give 2 points. One being that there is an incredible documentary, I don't remember when it came out, good 10, 12 years ago, but it's called, oh my gosh, now I'm gonna forget it. But it basically uses a Chernobyl documentary, and it basically models that as if it was a global scale. And it's called Life After People. It's called Life After People, Google it, it's amazing. And it is a short 2-hour documentary that basically takes the Chernobyl and basically models a global nuclear disaster. Now this bleeds into modern research that only came out in the last year or two, which has done hard ecological estimates of biological recovery through evolution. So we know what we've already lost and what we are unable to prevent from losing is about 20 to 30 million years of evolution to recover the biodiversity that we are experiencing the loss of during this mass extinction, the anthropomorphic one caused by us. But if you look at that, this amazing documentary kind of gave some modeling, and it basically showed that, life will go on without us. We're going to cause our own extinction, but even with our greatest nuclear power, knock on wood, we do not have the ability yet to remove all life on Earth and destroy all the soil bacteria. There's very few instances of lack of soil bacteria completely, even in Chernobyl, where it's been removed. And so life will, find a way. Love Jurassic Park. But I think it's even more relevant to quote Fallout, if you're watching the new series. It's amazing, okay? And one of their quotes, yeah, right? It's so good. So one of the best things I love, and I love seeing apocalyptic stuff because it gives me hope that we're not that bad yet also. But their quote is that everybody wants to save the world, they just have a different idea how. And that's why people who know how to do it with the best methods, the scientific method, need to unite across fields and everything to go, it's never too late until the day I die. I will do all I can. And at the end of the day, we'll say, we tried our best, we did what we could in our lifetime, and it mattered. And if the world goes on without us, I think a lot of us in this room would be okay with that. Because at least the species in the world survived, and we tried our best, and we didn't take down the whole system with us. But it's environmental science is depressing, but I think we have to find a way to continue to unify regardless of the negativity, so.
No, I really appreciate that.
Laugh through the radioactive fallout, okay?
Right, yeah. Yeah, it's not that bad. So TV says. Well, one, I want to thank all our panelists, one, for sharing all of your great thoughts and your perspectives. I also want to thank the audience for listening, and hope you will take some time when we're all talking for the next couple hours about thinking about the things that you're already doing that are hard and difficult, and remembering that we're all here to do hard and difficult things together. And maybe you'll feel a little more motivated to go out tomorrow and do some more hard things. So with that, thank you, and thank you, panelists.
Okay, so I'm closing it out. Okay, first off, Joanna froze in her very important closeout question of what was her favorite day in the field. So I'm going to tell the story of Joanna's favorite day in the field, which was also my favorite day in the field with Joanna. So we are driving through our new property, which is one of the field trips tomorrow, Sunrise Ranch. We're going to go through there tomorrow. We're driving in a truck, not slow either. One of our engineers is driving. And we're cruising, and all of a sudden, Joanna goes, "Stop!" and jumps out of the truck, before it even stopped moving. And she's like, "Spadefoot toad tadpole!" And she's gone. She literally saw a tadpole of a spadefoot toad out of the corner of her eye in a moving vehicle and jumped. That's how much this lady loves conservation biology. So that was a great day in the field, Joanna. Okay, I want to say a few words of thank you to our amazing team, San Bernardino Valley crew, all of our sponsors and our volunteers on the program committee. They killed it. It was amazing, so organized. Made all of our fellowship and happy thoughts possible. So thank you all for your very hard work. We really appreciate you. Round of applause. I don't think any of my board's still here, but I do want to give a great moment of thanks to our board who continues to sponsor this every year. It's not something that's typical for a water agency, and it shows a bold courage on their behalf to sponsor something that really focuses on the innovation of biology, science, conservation. So I'm very grateful to my board, and I know that they were happy to meet all of you. I do want to point out my hat. Really hard, not equal sign, impossible. The mathematical symbol for not equals means it is not equal. Those two things are not the same. So everyone keep that in mind going forward. Yes. And I hope to see you, one, at happy hour, but also out in the field tomorrow on the field trips. I think it's great to get everybody out there. I believe there's no bathrooms, so everybody be prepared for field peeing. Just want to say that real quick. And finally, in order to wrap this up, I will say it is a hard time to be a scientist right now, especially if you're a federal scientist. I'm so glad to still see USGS in the room, U.S. Fish and Wildlife Service. Thank you for coming. I heard they had to write a mountain of paperwork to get themselves here to defend the need to be here, so we really appreciate that. But I want to encourage everyone, as a scientist, as a conservation advocate, that it is really hard. And like Lindsay said, like, when do you give up? And I do not accept that we give up, like, ever. So, again, I bring in my hat. Really hard is not equal to impossible. We have to keep going. We can't give up. We can't become defeated. We have to, fund those important projects. We have to keep volunteering. We have to do all those things. Because if it's not us who's going to do it, then who are we waiting for, right? Like, we have to take that moment to do it ourselves. So I'm going to close out this awesome day in the words, as a true Gen Xer, 90s kid, in the words of the great and always relevant Rage Against the Machine, it has to start somewhere. It has to start sometime. What better place than here? What better time than now? We'll see you at happy hour.